Hello everybody, my name is Jose Luis Chacon, and today I'm going to show you how to model a 2D wind tunnel with the frequency of 60 Hertz of electric motor containing the initial velocity that is going to be calculated here. Okay, so the first step is going to go to ANSYS Workbench. We go here, we select Fluent, and then we drag it into the project schematic. Okay, when we have Fluent, we go to geometry and we start designing it. If you have it in SolidWorks, we can just simply design it here. Okay, we use the design modeler, as you can see here. Let me drag it, and then we go to the specifications that the project wants us to do. Okay, so the first step is gonna be go to XY plane, and then we go to look at. Okay, we just do a small zoom here. We have a better view of the plane. So what we're gonna do first is the cylinder chamber. Okay, we're gonna do a vertical line right here. If you go to sketching, we're gonna see a second. It's not loading for some reason. Hold on. Okay. We go to sketching, and what we're gonna do is simply use a line. We draw a vertical line from here to here, and we go to constraints to add a midpoint. Okay, we make sure the midpoint is just on the middle right here, and then we're gonna do is find a, let's see correctly here, hold on a second, we go to dimensions, and then we go to general, and we're gonna do is provide the height, which is gonna be 22 inches. We're gonna change the units to inches. We're gonna grab 22 inches. Okay, then we're gonna zoom in because we got way smaller, and yeah, here we go, we have the 22 inches of height of the cylinder chamber. Okay, the next step is simply drawing another horizontal line. In this case, we're gonna go to sketching again, we're gonna go to draw, and we're gonna draw a line on horizontal. This horizontal is gonna be the length of the cylinder chamber. Then we are gonna have a contraction right here. Okay, something like this, and then we're gonna have a horizontal testing zone, and then we're gonna do an expansion here for the diffuser. Okay, all right, now we have to fix these dimensions. So the first step, simply going to this vertical distance. So we're gonna use a dimension of 3. We're gonna do 3 inches because the test section height is 6, and this is the half. Okay, so now we have that distance, and then we're gonna do more distances here, more dimensioning. And if you remember correctly, or if you see it, the contraction chamber is 24 inches long. Okay, so we're gonna do 24, and then we're gonna do a diffuser length of 42 inches. Then what we're gonna do is an angle here. We're gonna do the angle this line and this line because it's a half diffuser angle, and we can either do this way or the other. I'm gonna select the upper one. It allows me to. It's not super user friendly, but yeah. Here we have 165, right? So let's try doing a 177. See how that goes, and yeah, this is supposed to be looking like this. So this is gonna be 3 angles difference of the half diffuser angle that we want. Okay. Now we have all of the dimensions here, but this one right here, this one is still missing H6, which is gonna be the sealing chamber length of 15, and then here we have the whole dimensioning. We still have to do the testing here. That is gonna be a test section of 12 inches. Okay. Now, if you look closely, we have all of the dimensions ready. And now we're gonna go to modify, and we're gonna select all of these lines, and we're gonna replicate it. We're gonna do it in a 180 degrees. Okay. And we're gonna paste it here, but we're gonna right click and we're gonna go to flip vertical. Okay, this is gonna make it like this. And then we have to paste it with this border right here. So we're gonna zoom into, and as closely as possible, we're gonna paste it. Okay. Okay. Maybe if you look closely, just be careful. It's not super close, right? This is not having an automatic alignment. So what we're gonna do is just drag it. Okay, and we're gonna put it together. Okay, we're gonna put these two together. There we go. All right, so now that's connected, and then what we're gonna do is close this design of the wind tunnel by just adding another line here, and now it's closed. Okay, as you can see here, the light blue is because it doesn't have the dimensions yet, so we're just gonna do it again because it didn't copy correctly, because that's the function that is not doing it. It's usually like that. So we're gonna go to H8, and that's gonna be a length of 15, and then we're gonna do contraction, which is gonna be 24. Okay, then we're gonna do the testing, which is 12, and then we're gonna do the expansion of the diffuser to be 42. Okay, now there's one thing missing, which is the angle here, and we're just gonna go to angle, then we're gonna do it the same way, just the opposite, which it should be the same in terms of what we want. All right, so now this is complete. The next step is going to modeling. Then you select explain, you expand it. Then you go to sketch, you select all the sketch, and then you go to concept, and then you do a surface from the sketch. Okay. The next step is applying the surface, and then you generate it. Then boom, you have the whole surface to the surface that we want, and then we simply just close it. Okay, now this is created. Just in case you want to save it, and we just go to project one, then we're gonna do this one, but as for the video. Okay, now we simply go to mesh, we go to um, physics. Yeah, these are the physics that we want. We make sure that the analysis type is made in 2D. Okay, and then we go to mesh, we open it. And we wait a little bit. Okay, still loading. Okay, we wait a little bit. All right, we're back here. So we go to mesh. We go to um, method. We go to method right here. Then we do a geometry selection right here. And then we apply it. Okay. Then we're gonna select the method of triangles, and we're gonna generate it. Okay. Now that is ready, you go to the mesh. We're gonna select this, but then we want to use sizing, and to improve the quality of the mesh, we're gonna select an element size of 0.01. Okay, make it smaller. You're gonna see it in a minute how it's gonna look like this. Okay, then we're gonna select these with the control. We're gonna select all these borders right here. We don't want the inlet or outlet yet, just the wall. And then we're gonna insert a labeling. So we're gonna go to create a name selection. Okay, this name selection is gonna be called wind tunnel wall. Then we're gonna go to the inlet right here, and then we're gonna go to create name selection, and we're gonna name it wind tunnel inlet. We're gonna do the same for the outlet. Gonna go to create name selection, outlet. All right, so now our mesh is ready. Then we're just gonna close this, and we're gonna go to workbench. We're gonna update this. All right, after waiting a little bit until the mesh was completed, remember we have to go to setup. Then we're gonna open it. It's gonna load and solver processes of one, but we can do two. And it's gonna load. Right now, the solver for Fluent is loaded, and we're gonna go to the energy. We want an energy equation, right? So go to model, and we activate this like that. All right. Then the next step is go to using a viscous model. So we're gonna open it here, and we're gonna do a K epsilon right here. We want to go to enhanced wall treatment. Then we're gonna have pressure and thermal effects. Okay, then we go to OK. Now it's time to set the boundary conditions. We go to inlet. Okay, now it's the important part of setting the velocity inlet. We're going to consider a continuity equation of V1 H1 equal to V2 and H2. In that case, we're going to use the information given from the formula that it was given to calculate the velocity inside of the testing section. So with that information in mind, we're gonna obtain a velocity of, after calculating a little bit, we got velocity of 3.97. You're gonna see it more clearly here. So 3.9715090991. Okay, remember that the dimensions given were in inches, right? We have here in meters per second, and the function was in meters per second. But because it's a ratio, then everything balances, and we will have the same magnitude in meters per second. Okay, but just be careful always with the units. Okay. All right. Now this is the velocity. This is the velocity inlet, and we apply it. Now we close it, and the next step is going to initialization. Okay. Then we go to run calculation, and we're gonna do a number of 250 iterations. In this case, considering it's a 60 hertz frequency, and then we're gonna calculate. Okay. It's gonna be running like this. All this data, all these values you're gonna see, and the last steps are pretty simple. We're just gonna get to see the results, and I'm gonna show you real quick how you can do that. It's pretty easy after this is run. All right, as you can see, the calculation was complete. So we just go to graphics and the contours. That's if you wanna do contour visualization, and you can select uh, here. We want to do um, want to use the midpoint that we wanted to do. Okay, we select all of these, and we're gonna see the static pressure. Okay, like that. All right. That's how you see the contours for different pressures. It's not only for static, but you can see the dynamic, the total pressure, and you can also see, as I said, the dynamic. You can see the velocity right here, and etc. Then if you want to see the plots, you just simply go here, go to new, and we're gonna create a new surface point. Actually, it's gonna be a line, but it's gonna be on the midpoint, okay? So we're gonna do 0 to the midpoint, which we recall from our design, this is gonna be 2.3259, okay? And then this is my line 4, and save the plot. Then you can see that. That's the static pressure. You can see the total pressure, and you can also write a file if necessary and order points, and you just get the data in an Excel file. You just have to write it as XY, and then when you have the XY file, you just put a point CSV, and then you get the data. Okay, that should be everything. Thank you very much.